Right, let's assemble the team and dive straight into this explainer. Think of your Cambridge 0625 physics exam as a high-stakes bank vault. To pull off the perfect grade, you need a flawless strategy and the right master keys. Today, we are decoding the exact symbols and units you absolutely must know to secure those top marks. We see two types of students fail this heist all the time. First, you've got Alex. Alex overloads their answers with raw physics facts, dumping information onto the page without any real analysis or structure. Then you have Sam. Sam rushes the paper, entirely missing the specific requirements hidden inside the command words. If you've ever felt like physics is written in an ancient, indecipherable language, and you find yourself making Alex or Sam's mistakes, you are not alone. But today, we are translating that language into a foolproof strategy. Mastering this isn't just about memorizing random letters. It's about fundamentally understanding how the physical world is measured, communicated, and graded.
Here is the master blueprint for our heist. We are systematically breaking into 6 informational vaults today. We'll start with the physics language code to get our baseline strategy. Then, we hit space, time, and matter, followed by motion and forces. After that, we crack into energy, work, and power, sweep through waves and light, and finally extract the goods from electricity and radiation. By the time we finish walking through this floor plan, you are going to have a rock-solid mental framework for your upcoming exams. No more guessing, no more dropped marks. Let's get to work.
Vault number 1, the physics language code. Now, what's really interesting about this syllabus is how it scales the required precision depending on whether you are taking the core or supplement paper. This is where command words become your best friend. A command word like state requires a simple fact, while explain demands our specialized PEEL framework. That stands for point, evidence, explanation, and link. Top students structure the physics answers by explicitly linking their PEEL points to the correct, highly precise units. If you get the unit wrong, your evidence falls apart, and the examiner locks you out of those marks.
Before we continue, subscribe to our YouTube channel Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, look closely at this comparison. Notice how the supplement tier demands a microscopic resolution of precision, introducing milliseconds, microseconds, and milligrams into the mix. This is exactly where our student Sam rushes and loses points. If you're on the core paper, you're mostly dealing with human scale time, hours, minutes, and seconds. But for the supplement students, the scale shrinks dramatically. If a question gives you time in microseconds and you don't convert it based on these unit standards, your entire calculation is busted. The examiner's red pen is going to be all over that answer.
Let's move to our second vault: space, time, and matter. These are literally the building blocks of reality, and they're the foundation of your exam strategy. We are going to apply our tactical breakdown here so you can see exactly how the dimensions construct the physical world you'll be tested on.
This perfectly illustrates how the fundamental unit of length steps up mathematically. Look at the sheer variety of symbols we use just for one-dimensional distance: L for length, H for height, D for distance, S for displacement, X for extension. They all share the base unit of the meter. But watch this strategy unfold. Step it up. Multiply length by length, and your unit literally squares to meters squared for area. Multiply it again, and it cubes to meters cubed for volume. It's a visual representation of how physics units logically build on one another. If you ever get stuck on an exam, trace the math backwards through the units.
All right, pay close attention because this is the classic trap that our other student, Alex, falls into every single time. The crucial point is to never, ever confuse the raw amount of matter in kilograms with the gravitational force acting upon it in newtons. Let's transform Alex's thinking right now. Imagine erasing the red marks and ticking the green check marks. Mass, symbolized by an M, is intrinsic. It's measured in kilograms. It doesn't matter if you are on Earth or floating in deep space, your mass is locked in. Weight, however, gets the symbol W. It is a force, completely dependent on gravity, measured in newtons. Keep these two distinct, use them correctly in your PEEL paragraphs, and you instantly save yourself from throwing away easy marks.
Vault number 3. Motion and forces. We are unlocking the kinematics variables now. This is where we take those basic building blocks and put reality into motion. How objects interact and move is one of the most heavily tested areas in the 0625 syllabus, so you need absolute precision here.
By grouping these units, you can visually track how speed evolves into acceleration. Speed gives us our baseline rate of change, meters per second. But when speed itself changes, we get acceleration, our A, and our unit gains a dimension of time in the denominator, becoming meters per second squared. Now let's tie this to our exam strategy. If the command word asks you to calculate momentum, you take that speed and multiply it by mass, giving you P, which yields the unit kilogram meters per second. And the change in that momentum over time, that's impulse, measured in Newton's seconds. Memorize these links, they are your cheat codes.
You have to be extremely careful here because the symbol lowercase g carries a high-stakes dual identity. This is another area where Sam rushes and loses points. Are you measuring a falling acceleration or the strength of a gravitational field? If you're describing an apple dropping, g represents the acceleration of free fall measured in meters per second squared. But if you're calculating how hard a planet pulls on an object on its surface, g is gravitational field strength measured in newtons per kilogram. Mathematically, on Earth, both value out to roughly 9.8, but the command word and the context of the question dictate which unit you absolutely must write down to prove you understand the physics.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, getting back to the strategy. When documenting interactions, remember that pressure can be expressed as newtons over area, but supplement students must also recognize pascals. Force is your straightforward push or pull in newtons. Stretch a spring, and you're looking at the spring constant K in newtons per meter. But spread that force over an area, you get pressure, lowercase p. Core students stick to newtons per square meter. Supplement students lock in the pascal, or PA.
We are now entering Vault 4. Energy, work, and power. Think of this as the system's fuel. It's time to shift gears into our interactive workshop. We're going to put your data extraction and writing speed to the test. Let's see if you can apply these units under pressure.
Welcome to Challenge 1, the data scan. Imagine a 60-second timer ticking down on your screen right now. Scan this table. What's the core trend? I'll tell you. It is absolutely essential to recognize that while work and energy share the joule, power represents the rate of that energy transfer, stepping the unit up to watts. Work done, symbol W, and energy, symbol E, both use joules. Doing work is just transferring energy. But introduce time, asking how fast that energy moves, and you arrive at power, P, in watts. If you miss the kilowatt hour for energy during your scan, make a note of it. Examiners love testing that in household electricity questions.
Moving to Challenge 2, find the flaw. Look at specific heat capacity, lowercase c. Imagine Sam writes a paragraph explaining this, but forgets the degrees Celsius in the denominator. The examiner spots the flaw instantly. The unit joules per kilogram degree Celsius perfectly acts as a formula in disguise, telling you exactly how many joules it takes to change the temperature of a specific mass. By just reading the unit out loud, you know exactly what it means. It ties directly into our temperature symbols, theta or T, measured in Celsius or Kelvin. If you blank on the formula during the exam, don't panic. Just look at the unit. The formula is literally built right into it. That is a massive hack.
Vault number 5, Ways in Light. The unseen mechanics. This section requires immense precision because you are dealing with phenomena you can't easily visualize. Let's set up our third interactive challenge.
Challenge 3, speed writing. You have 30 seconds to mentally draft a PEL paragraph explaining wavelength to an examiner. Go. Notice how the supplement tier once again shrinks the scale, requiring you to utilize nanometers when dealing with the incredibly small wavelengths of light. Frequency uses the hertz for waves per second. Wavelength, the Greek letter lambda, uses meters. But light waves are tiny, so supplement students must confidently use nanometers. And here's an examiner's secret. Do not confuse the lowercase f for frequency with the lowercase f for focal length. Context is everything. If your 30-second paragraph mixed those up, you just lost the mark.
Still in the optics vault, keep a sharp eye out for the refractive index. This is a rare anomaly in physics because it's a ratio and therefore it has absolutely no unit. When dealing with rays of light hitting lenses, you're constantly using angles. Incidence, reflection, refraction, and the critical angle all use the standard degree symbol. But the refractive index, lowercase n, stands alone. It's calculated by dividing a speed by a speed. The units completely cancel out. If you try to force a unit onto your answer for refractive index, the examiner knows you don't actually understand the concept. It is purely a number.
Finally, we are breaking into our last vault, electricity and radiation. These invisible forces require a highly specific language, especially when dealing with circuits and atomic decay. It's time to consolidate everything into our final answering system.
Think of this table as your ultimate cheat sheet for circuitry.
You must visually separate the current flowing in amperes from the static charge measured in coulombs. This is rule 1 of our final system. Command word decoding linked to precise units. The symbol V is wonderfully consistent for voltage, but EMF gets an uppercase E yet is still measured in volts. Current gets I for amperes, resistance gets R and the omega symbol for ohms, and charge gets Q for coulombs. Applying the Peel framework here means making sure your evidence perfectly matches these defined variables. Don't mix them up.
When calculating atomic decay, your units of time expand drastically, scaling from mere seconds all the way up to years to accommodate different half-lives. This brings us to the third rule of our system, the time management matrix. You have to adapt. Count rate is simple, counts per second, but half-life forces you to be flexible. Some isotopes decay in seconds, others take millennia. Listen up, because this is the social proof you need. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. You have to put the reps in to master this matrix.
And sitting at the absolute edge of our syllabus is the Hubble constant, carrying the highly unique unit of per second. Found in astrophysics, h0 describes the expansion rate of the universe. The unit is s to the power of -1. It is a profound way to wrap up our syllabus sweep. Now here's your final reminder: subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by without having the ultimate strategy in your back pocket.
Think about it. Mastering this foundational language of physics is the ultimate cheat code to locking in every single point you deserve. Examiners ruthlessly dock points for naked numbers or mismatched scales. If you use the Peel framework, decode the command words, and apply these exact units, you become unstoppable. You won't make Alex's factual errors or Sam's rushed mistakes. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.